Okay, today we're going to work on solving rationals. Again, this is the third day. Now we're just doing the application part of it. This is all the word problems. So it's very, very important to make sure we organize the data that these problems give us. Okay, so number one says Troy can do a particular job in 4 hours, and it takes Mason 6.5 hours to do that same job. So there it gives us two pieces of information. So I'm going to kind of collect that data and kind of organize it in my own special way. So I know that Troy, okay, does one job in 4 hours. So I just create a ratio, right? And then I know that Mason can do that same one job in 6.5 hours. And so I've organized my data over here, and then it wants us to know how long will it take them to complete the job if they work together. So I'm just going to write together down here, and we want that one job in I don't know how much, okay, how much time. That's what we're trying to figure out. So essentially, we have Troy, we have Mason. So if we take how long it takes Troy to do that job and we add it to how long it takes Mason to do that job, then we should equal how long it takes them to do this together. Okay, so keep in mind, everything we do now has been dealing with fractions. So these ratios can just be turned into fractions. So if I take Troy, so I'll label it Troy, 1 over 4, so I keep it as a fraction. Okay, still the same thing as a ratio. And I add Mason, that one job in 6.5 hours, then I want to know how long is it going to take them together. So that's one job in, if I don't know something in mathematics, we use a variable, okay? Most common variable is X to use. So we have Troy plus Mason equals together. And so now this is kind of a problem, or it looks familiar. It should look familiar. It's a problem that we've been working the last few days. Okay, so the hard part about today is going to be able to organize your data and then write your equation. Okay, so if I'm solving this equation, I do need to multiply by the least common multiple, or the common denominator. Okay, so I really want to eliminate every variable in the denominator. So I'm simply going to multiply by 4, by 6.5, and by X. Okay, so I multiply those out and distribute those out, right? So when I distribute these out, then this is what I'm left with. I have 6.5x plus 4x is equal to 4 times 6.5 is 26, I believe. And so now I just start working this equation. This gives me 10.5x is equal to 26. Then I divide by 10.5. And so I get an answer of 2.48. So about 2.5 hours is how long it should take them to complete the job together. Okay. Then it asks us about part B. It says, what if Troy works with Chris instead? It says they can finish the job in 1.33 hours. How long would it take Chris to work alone? Now, so now this time we have Troy's information still. Takes him 1 and 4. We have something about Chris, but we don't know how long it takes him to complete this job. And this time we know that together they finished that job in 1 1/3 hours. Now, I don't like that mixed fraction, so I'm going to change this to an improper fraction. So 1 1/3 becomes 4 over 3. Okay, so I just changed it to a fraction. Instead of a mixed fraction, an irrational fraction, right? 4 over 3 is the same thing as 1 1/3. So now I have my information. So now I write my equation. 1 over 4 plus 1 over x, because I don't know how long it takes Chris, is going to equal 1 over 4/3. Okay, now this is the weird part. We have a fraction within a fraction. Okay, so I want to undo that. I want to get rid of that, right? So if we think about it, if I have, just looking at this right part right here, if I have 1 divided by 4/3, remember fractions, we keep it, change it, flip it. So we have 1 times 3/4, which is just 3/4, right? So essentially, 1 divided by 4/3 is just 3/4. So I can do it this way. Okay. And so I change that to be 3/4. Okay, because 1 divided by 4/3 becomes 3/4. If that doesn't make sense, then I would just get a calculator, and I would do the fraction, and then I'd put 1 over and then 4 divided by 3, and when you enter that, it gives you 3/4, right? If it gave you a decimal, then it would be 0.75. You can convert that to a fraction. So that's another easy way to kind of do that, right? So here is our new problem. So now I need to solve this problem. So I multiply again by the LCD, the least common denominator. So I need to multiply by the least common denominator, also known as the least common multiple. In this case, it is 4x. So then I distribute 4x to every fraction. After I do that, what I have left is x plus 4 is equal to 3x. And then I start to solve this equation. Subtract x to both sides. That gives me 4 is equal to 2x. Then I divide 2 to both sides. And that gives me x is equal to 2. So it would take Chris 2 hours to complete that one job. All right, moving on to number 2. Number 2 says, Anita and Martin are assisting managers for marketing department of the Snarky Larks hockey team. The hockey season is fast approaching, and the rink board ads need to be mounted to the rink boards before the season begins. Anita's team and Martin's team have taken turns during each year. It has taken Anita's team, 20 hours to attach the ads. So Anita does one job in 20 hours. So there I write down my information. It takes Martin's team that one job in 30 hours. This year their boss wants them to work together to get the job done faster. How long will it take if the team works together? So I know that I'm going to add those two to figure out how long it takes together. Again, that's not what we know. So I'll end up using a variable for there. So now I can write my equation. Anita does that one job in 20 hours, plus Martin, one job in 30 hours, and we want to know how long it takes them to do it together. Okay, so an easy way to do the LCM is I multiply. I'm just going to multiply by everything that is in the denominator. So 20, 30, and x. Okay, so I just literally put the denominator out in front. And so now when I distribute in this first fraction, what I have left is 30x plus 20x is equal to, and then I have 20 times 30, which gives me, I believe, 600. Okay. And then I start solving this. 30 plus 20x gives me 50x. And then I have to divide by 50 to both sides. So x is equal to 12. So if they work together, they can get it done in 12 hours. Okay. I'm going to skip down to number 4 because number 4 is very similar to the ones we've done just now. Ramiro can rake a lawn in 2.5 hours, and Dwayne can rake the same lawn in 2 hours. So again, if I have my ratios here, Ramiro, 1 job in 2.5 hours. Dwayne, 1 job in 2 hours. How long will it take them to work together, right? So now I can just start putting my ratio of 1 to x. So let's write our equation. 1 over 2.5 plus 1 over 2 is equal to 1 over x. Okay, so then again, I multiply by the LCD. So I just multiply by everything in the denominator. That's probably one of the easiest things to do. I distribute. After I distribute, what I have left is 2x plus 2.5x is equal to 5 because 2.5 times 2 is 5. And then I start simplifying. This gives me 4.5x is equal to 5. Then I have to divide by 4.5 to both sides. So x gives me 1.1 repeating. Okay, so it will take about 1.1 hours for them to complete that job. All right, now let's come back up to number 3. The reason I kind of went out of order is this one's actually going to be a cross multiplication. So it's set up a little bit different. So this says Jordan has made 11 of 25 free throws in basketball. How many consecutive free throws must he make in order to raise his shooting percentage to 60%? So if I'm kind of doing this right, we know if I'm organizing my data, Jordan's already made 11 of 25. I know that to that, I need to add the number of shots that he makes, and I want the total to equal 60%, right? Okay, so one of 2 ways we can do this. We can say our first ratio, 11 over 25. Okay, and we need to adjust this ratio. So we have to understand how basketball works, right? So when the numerator right here is the shots made over the shots attempted, right? So if I need to make consecutive free throws every time I shoot the ball and make it, I have to add it to both the top and the bottom. So I have to add the number of shots I made with the number of attempts. And since we're assuming that he's going to make consecutive free throws, we're going to assume that every shot he takes now is a made shot. So we shoot one and we have to add it to our made shots, and we also have to add that to our attempts. Okay, so for instance, if I shoot one and make that one, then now I have 12 over 26. And it just keeps going up like that. So this is our adjustment, right? Okay, so that's what's kind of different here. And we just kind of have to understand a little bit about basketball, right? And so now we can work this 2 different ways. I want this to be 60%, so I can do 60% over 100%. Okay, or if I didn't want to work with percentages, I could change this to 0.60. So I just changed the percent to a decimal. So you can work it either way, you'll still get the exact same answer, okay? I'm actually going to work with this left one, even though it has a little higher number. So I'm going to cross multiply this. So that's going to give me 100 times 11 plus x is equal to 60 times 25 plus x. And then I start solving this. I distribute here. So that gives me 1100 plus 100x is equal to 1500 plus 60x. And then I start solving. So I'm going to move the 60x over. That gives me 1100 plus 40x is equal to 1500. I'm going to subtract 1100. That gives me 40x is equal to 400. I divide by 40. X is equal to 10. So he would need to make 10 consecutive free throws in order to reach his goal of 60%. Okay, an easy way to check it. If I add 10 to both 11 and 25, then that means he has 21 over 35. And then I can just check that in a calculator. 21 divided by 35 does in fact give me 0.6. So that's 60%. All right, moving to the back side. Again, let's go kind of a little bit out of order. I'm going to do number 6. So it says you travel 10 miles on your bike at the same amount of time that your friend takes to travel 8 miles. If your friend rides his bike 2 miles per hour slower than you ride your bike, find the rate at which each of you is traveling. Okay, so anytime you're traveling, you need to understand that this is the simple formula we use. Distance is equal to rate times time. Okay. Now, as I read this, I ask myself, what's the same between myself and my friend? And what's the same is the time. So since that's the same, I know that if I solve this equation for time, okay, then I just divide r to both sides, right? So time is equal to distance divided by the rate, okay, because I just solved it right here. So I know that if I can find the time it takes me and set it equal to the time it takes my friend, then I should be able to figure out this problem. Okay, so now I'm just looking for anything that tells me time, distance, or rate, right? So let's look at that. So for me, so we'll just say me, and then my friend. Okay, so for me, it says I traveled 10 miles. Miles is distance, so that's going to be in the numerator. In the same amount of time, we don't really know the time, that it takes your friend to travel 8 miles. So again, distance again for my friend is 8. It says if your friend rides his bike 2 miles per hour slower than you ride your bike, find the rate. So we're trying to find the rate. We're trying to find the denominator at which each of you is traveling. So we don't know how fast we are going, so we're going to use an x, right, for both of us. But we do know our friend rides 2 miles per hour slower, so we know that his rate, so if my rate is x, his rate is going to be x minus 2, because that means it's going the same speed as me minus 2 miles per hour. So now I have my two fractions and I just set them equal to each other. So this is another one that is cross multiplication. Okay, and you can tell they're a little bit different to set up, right? And so now I just cross multiply. So I get 8x is equal to 10 times x minus 2. I start to solve this. Okay, I'm going to go ahead and subtract 10x to both sides. So that gives me negative 2x is equal to negative 20. Divide by 2 to both sides, and I get x is equal to 10 miles per hour. So I should be riding 10 miles per hour, and my friend would be riding 8 miles per hour because his rate is 2 miles per hour slower than mine. All right, and then number 5. Okay, 5 is going to seem very complicated, but really it's just because we have to write down the math involved with this. This I feel like you guys could figure out, right? It says a high school group is planning a field trip to Florida and needs to determine how much each student must contribute. The cost to charter a plane, so we're going to fly there, is $5,000, and every person must also pay $300 for the cost of this food and lodging. So this is how I want to break this down. Okay, so this $300 is what all of us are going to pay. Everyone must at least pay $300, right? And then the $5,000, since we're chartering that plane, it costs $5,000 for the plane, but not all of us are going to pay $5,000. We're actually going to split this cost, right? So we're going to split that. So that's what I want you guys to keep in mind. We're all going to pay $300, and then we're all going to split a certain amount based on how many people go. So it says write an equation to determine the total cost. So if we use x and y, right? Y being the cost, right? Each person is going to pay, and x being the number of people going, then we can kind of figure this out. So if x represents the number of people going, y represents the cost. So the cost of each person is going to equal the $5,000 divided by how many people are going plus the 300. Okay. And so now we're kind of putting our rationals to work here. So now it says if the cost per student can be no more than $500, so this is my y, what is the minimum number of students that must go on the trip? Okay, so we simply use this equation and we plug in 500 for y, and then we solve for x. Okay, so when I solve this equation, I need to subtract 300 to both sides. That leaves me with 500, oh, not 500, sorry. 200 is equal to 5,000 divided by x. Okay, here, now I can just simply cross multiply, right? So we have 200x is equal to 5,000. I divide by 200, and that gives me a total of 25. So this number is going to be the minimum. Okay, so I want at least 25 people to go. Okay, so because I don't want my out-of-pocket expense to be more than 500. So if 25 people go, I'm paying 500. Okay, so 500 is the most you're going to pay. So obviously, the more people that go over 25, the less you pay, right? So we want more than 25 people. So now I have another restriction. Part C says if no more than 100 students fly, so now this is my x because it represents students. on the charter plane, what is the minimum cost per person? Okay, so it can hold up to 100 seats, right? So now I use that same equation up here, and now I have y is equal to 5,000 divided by 100 plus 300. So now I'm dividing 5,000 by 100, which gives me 50 plus 300. And so y is equal to $350. So this represents the minimum cost per person. Okay. So now we want to figure out a reasonable domain and range. Reasonable, this term right here just means like what makes sense in the context of your problem, right? So if I'm thinking about domain is the X value. So anything that deals with students. So I'm really going to use what I found in C&D to figure that out, right? So if I'm looking at this, I have 100 up to 100 students. Sorry, and I'm going to include B here, but 25 represented students too. So if we remember the restrictions that we were given, I want at least 25 students, and at most 100 students can go. So that is my domain. So my domain is 25 to 100, because again, the lowest number of students I want is 25. The maximum number of students that I can take is 100, because the plane only seats 100. And then the range is anything that deals with the cost, right? So we had a cost of 500. We did not want to pay more than 500. So this is going to be our high extreme. And then we figured out the cost right here of 350 is the lowest we're going to pay. So the lowest amount we're going to pay is $350. And the highest we're going to pay is 500. Okay, and so that would be my reasonable domain and range. And then the last one, this one's just review, guys. It says the number of hours it takes for ice to melt varies inversely. Okay, so I'm going to make this quite simple. I'm going to show you the simple way first, and then I'm going to show you actually the mathematical way here in a minute. So remember, it's going to give me two values that go together. So it says, suppose that 65 degrees, it takes 2 hours. So I'm going to multiply 65 times 2. Okay, and I'm going to do this down here both times because I'm really trying to solve these. So I take 65 times 2, and then it gives me another value. So don't worry about this 1 square inch. That's just telling you how much is going to melt. So it says determine the temperature at which 1 square inch of ice would melt at 4 hours. So I take the two numbers that go together, 65 and 2, and I multiply them, and then I divide by the other value it gives me. Okay, part B, determine how long it would take to melt 1 square inch of ice at 45 degrees. I take the two that went together, 65 times 2, and then I divide by the other number. That's what we do essentially when we have varies inversely. So then I just work that out. For A, I get 32.5, and this is actually degrees. And then down here would be about 2.8, and this represents the hours, how long it would take. Okay, so formal way of doing this. The first thing you do is find the constant of variation, which is multiplying x times y. Then we would write an equation in the form of y equals k over x. And then the third thing would be we would solve, right? So k is just our two numbers multiplied together. 65 times 2 is 130. our equation would be 130 over x. And then we would use this equation to solve a and b. Okay, and it's essentially the same thing. You take that number and you put it in the bottom for x. 130 divided by 4. 130 divided by 45. And it'll give you your answer.